network that's located in a single building is what we call a local network, or an LAN. And if you're using a connection with an internet service provider to connect your network to another building, then we're talking about an extended network, better known as a WAN, wide area network. The localness of a network has nothing to do with size, so a network with 2 PCs is as efficient as 5,000 PCs in one building. Ethernet is the protocol we use on our local network. It's found mainly on the data link layer of the OSI model, but it's divided into 2 sublayers. There's the LLC sublayer, which is what takes care of the structure of the frame, and the MAC sublayer, which defines the protocol for accessing hardware. The MAC sublayer is the most interesting part for us. Each device on our LAN has a unique identifier on the data link layer. This is our MAC address. An IP address is a unique identifier on the network layer, layer 3, and the MAC address is also a unique identifier, but on the data link layer, layer 2. A long time ago, all computers on the same network were connected to a single, long black coaxial cable. This was our physical hardware. The topology used at that time with this type of cable was a bus topology. A network like this was semi-duplex, which meant that only one computer could send traffic, and the others had to wait. Nowadays, we have full duplex. That is, all devices can send and receive at the same time. In this example, if 2 computers send data at the same time, there's a collision. Electrical signals bounce off each other and both transmissions are lost. In the past, you would also sometimes see star topologies using a hub. The problem with the hub is that it's nothing but an electrical repeater. If you use a hub for your network, not only will you definitely have collisions, it will work as a half-duplex network. A hub is not the same as a switch. The way half-duplex works is like walkie-talkies. If we want to communicate, we press the button and talk. And in the meantime, others listen to us and don't talk. That is, you are the only one using the channel or the medium of communication. To get back to our MAC sublayer, on a half-duplex network, sure, a solution to avoid collisions is put in place. This solution is called CSMA/CD, Carrier Sense Multiple Access Collision Detection. This method defines how a machine will use the media on which it's connected. The CSMA/CD method works just like pressing the button on a walkie-talkie. When a network card sends data, the other cards only listen and don't talk. Let's move on to the Ethernet frame. Here, the most important fields are the destination address and the source address. This is where the MAC addresses fit in. In the first 2 fields, there's an alternating chain of O's and 1s to indicate to the receiver that an Ethernet frame is incoming. The length field corresponds to the size of our Ethernet frame. The header and data fields are where the data comes in. And at the end, we find the FCS field, which allows us to see if the frame is okay or corrupted. An MAC address is made up of 48 bits. The BC field stands for broadcast. If your Ethernet frame is a broadcast, then that bit will be set to 1. The local field should be set when you want to change your MAC address. An MAC address is unique in the world. If you make a change in this field, the impact will only be local, i.e. only on your network. The OUI field identifies the manufacturer among its competitors. And the last 24 bits are a value determined by the manufacturer to make this MAC address unique among all its network cards. The MAC address is written in hexadecimal. Here is an example of an MAC address. Let's move on to the different types of cables that exist. You've probably seen UTP cables before. There are two types: straight cables and crossover cables. Here's an RJ45 connector on a straight cable. And here it is on a crossover cable. The difference is how the wires are connected in the RJ45 socket. A straight cable has the same layout of the wires on both sides, and a crossover cable contains two inversions of wires, only on one side. Wire 1 is switched with wire 3, and wire 2 with wire 6. A straight cable is used to connect two different terminals, from a PC to a switch or a switch to a router. And a crossover cable connects two devices of the same type. For example, a PC with a PC, switch to switch, or router to router. The last thing you might see about cable types is the rollover cable. This is the cable that allows you to set up a switch or router from your PC.